I'll start the lesson while everyone's still coming in. So thanks again for spending your Thursday evening with us, and welcome back to the Cybersecurity Hacking Fundamentals workshop. My name is Brian Lee, and I'm a second-year computer science student at SMU. Some of you should remember me from the previous workshop, but I think because of the Ellipsis Tech series, we have a few newcomers. So if you are worried about catching up, just note that we have all the lesson materials and recordings available on our workshop's public board. So if you'd like to follow along the slides, you can find this week's slides on a Padlet and all the previous recordings and slides. So I'm joined tonight by my Vice President, Chris, who will be walking you through the hands-on activities, Tanya, who's currently recording this session, and the rest of the White Hat Society Exco, who will be helping me with any questions that you might have. And I'll just leave this slide for a little bit longer because this is what we need to use for this workshop. So if you have any questions or issues with downloading and installing this tool, just put it up to the Padlet and I'll answer your questions as soon as I get to them. And from the feedback we got last week, I'm glad that many of you found it quite easy to follow along, because I think we strive to get everyone on board and everyone to follow the content pretty smoothly. So I really appreciate all the feedback you guys have given us. And if you'd like us to improve the workshops in the future, just stay to the end and give us some feedback. And now today we'll be introducing the fundamentals of networking, network scanning, and going through some scanning hands-on with Nmap. And once again, before we move on, I would like to remind everyone that everything learned here is for the purpose of education only and shouldn't be used outside for any sort of malicious or illegal intent. So please practice discretion and care when doing any hacking. And as I said last week, please verify the legality of any sort of your actions before you actually do them. Essentially, just be ethical. Now, last week, we covered the cyber kill chain, which describes the general steps for a hacker and how they go through the process. We went in depth into reconnaissance, which is a passive observation method to retrieve information about targets. And this week, we will be focusing on scanning, which is the more active data gathering step. So like I said, scanning is an active reconnaissance method. Last week, we used a burglar analogy to explain the steps in the cyber kill chain. So we likened hacking to a burglar robbing a house. And with reconnaissance, we are passively observing, like burglars who are in a car, driving through a neighborhood and just looking for any sort of vulnerable homes. With scanning, we are more active in our search for vulnerabilities, and essentially it's like us going up to the door and checking for any sort of loose doors or windows. And of course, this provides us with more information, but it also gives us a greater risk of being detected. Therefore, we have to ask why we should actually scan any sort of targets. And I think a really nice word to describe it is just about your risk appetite. Scanning allows us to get more information about a target at the risk of getting caught. So as a hacker, you have to assess the situation and target very wisely. And the most common reference for scanning is of network scanning. So to begin, we first have to learn about computer networking. So don't worry, we won't go through too much of the details, but we will be covering some of the fundamentals as well as some practical applications of networks and how we can use them to scan for our devices. With computer networking, when we break it down, it's basically a combination of networking and computers. And if you look at it broadly, networking is just about systems of connected things. Therefore, when we talk about computer networking, we are simply referring to a system of interconnected computers. Some examples include the internet, or your smart home devices, or even your Bluetooth devices. If I'm If I'm losing any of you, just send any messages to the chat or to the Padlet itself. So fundamentally, why do we need networks? And it's an obvious question in hindsight, but essentially, it's about sharing resources with different computers. To give an example, imagine our society as a network of people. In the modern age, you don't really farm your own crops or build your own house. Instead, you have specialists like farmers and construction workers and architects who do these tasks for you and then share the fruits of their labor with the entire network, in this case, society. And in a way, it's the same with web services like YouTube and Amazon. Google, Amazon, they all have powerful computers that run these applications somewhere on the internet and then share the results with you. And some of you might have realized this, but the internet is basically a global, large computer network made up of billions of devices across the globe. And some of these computers are where Google and Amazon and other companies run their servers and share all these services with the rest of the world. But this begs the question, if there's so many computers on the internet, how do we find the one that we want? For example, how do we go to Google servers? And we solve, or at least a lot of smart engineers in the past basically solved this with the Internet Protocol or the IP protocol, the IP. So don't worry too much about what the Open Systems Interconnection Model is or the OSI model is, because we'll be covering this in depth next week. So if you're interested, just stay for the next one. Essentially, it explains how data is sent between two computers, from the very raw electricity between the two computers and the wires, all the way to how the data is formatted and transformed before they're actually read. And ultimately, the Internet Protocol is concerned with how we find devices on a network. So the protocol does this with what they call IP addresses, which lets us find specific computers on the internet. So treat them like the postal codes of the internet. And IP addresses come in two forms. The most common form being IPv4, which is simply four numbers ranging from 0 to 255 placed next to each other, separated by dots. But the issue is nobody expected the internet to be so massive and so large. And nowadays, we have a lot more devices than we do available IP addresses. Because there's so many more devices on the internet, engineers had to come up with a few solutions around this problem. And another solution they came up with was the IPv6 format, which is just a philosophy of using more numbers. So if you need more addresses, just throw more numbers at it. And IPv4 and 6 are the two IP addresses that we have right now. And I hope this helps you understand and recognize IP addresses in the future. And I mentioned before that an IP address is like the home address or the postal code of your computer on the internet. So it also makes sense that you can use these postal codes to find other computers on the internet. Therefore, we have our first hands-on activity. Let's try to figure out what our computer's IP address is. So for everyone who's at home, or for anyone who's in school as well, you can fire up your terminal and type in these commands. So for Windows users, there'll be your CMD, and for Mac users, you can use your terminal. Oh. Let me just perhaps give you guys a demonstration. Sorry, Jonathan, were you asking a question? I couldn't quite catch that, but if you like to ask a question, you can just put it onto the Padlet and we'll get back to you on that. So for Windows users, oh wait, give me a second, I realized something. Let me just put this side by side. For Windows users, you just ipconfig, and I don't think that's available on Mac. Yeah, it's not available, don't worry about that. But for Mac users, it's essentially the same command. And if you type this in, it will essentially tell you a bunch of addresses. And if you notice, we have 127.0.0.1, which is essentially your own device's IP address. But you also have these addresses start with 192. So these addresses are essentially what we call the your computer's own private IP address. So it's a pretty simple exercise, and I hope everyone is able to do this one, because as we move on, we'll be introducing more and more concepts. So I hope this is pretty straightforward. And don't worry too much about what grep is. It's just a simple program that lets you search for text within lines of text. So for now, it's not too much of a big deal. But if you'd like to know more about it, you can always look at the slides or just search it up online. And for me, I've gotten an address that starts with 192.168, but some of you might have gotten an address that starts with 10 or 172. So given that we have this address, right, what happens if we search Google for IP address? So our next hands-on exercise is essentially asking you to search for your IP address. So just go to Google and ask Google, what's my IP address? What is my IP address? And it will give you a public IP address, which is a completely different number from what we got before. So over here, I got this address, which is 116, but on my local machine, I got an address that is 192. And I don't think anyone in this entire class should have an address that matches. So everyone's address should be different based on the two different screens. So let me just put this back up on the presentation and get back to it. So we have a few questions for you guys. Firstly, why the IP address is different. And if anyone has any guesses as to what that is, just put into the chat. So any ideas? Public and private, yeah, exactly. So yeah, Yongjun actually has a pretty accurate answer, NAT, and we'll cover that in a little bit. But most of you are answering about public and private addresses. One is asking whether it's random and whether it's unique to each device. So this is a little bit of a interesting thing about IP. With IP, we have essentially what we call a network of networks. And Marcus answered basically about public and private networks, because we do have what we call private networks, which is essentially your routers and any sort of local area networks. But we also have your public network, which is essentially the wider internet. And the internet is just a decentralized, like I said, network of networks. And it's built from connecting multiple networks together. And just a quick little term, we also have what we call subnets, which is just the terminology we use for networks within larger networks. So don't worry too much about the terminology. The slides are always here for you to refer to. But with Qingru, he asked if the IP address is a random one. And you could treat it as random, but in reality, it's normally assigned to you by your ISP or your service providers like Singtel and StarHub and these kind of people. So these public addresses come from these larger corporations that handle the entire public IP space. So let's zoom into a private network. And in this model, your device doesn't connect directly to the internet. Instead, devices usually connect to smaller private subnets like a Wi-Fi network. And within this network, yes, we have unique IP addresses for every single device. And if you think about it, even the 4G network is basically a subnet of the internet, because the 4G is also what we call, is sort of like a private network. Ling Hui has an issue with grep, and I think we will handle that question in the Padlet. So we'll transfer the question to the Padlet and we'll answer that in a bit, okay? For now, let's just continue the lesson, and don't worry too much about not being able to get the IP address. So we have private networks, and in fact, there are a range of IPv4 addresses that are reserved solely for private IP addresses. So these addresses will never be used on the public internet, and that's why all your private addresses normally start at 192.10 or 172. In contrast, we also have the public network, which consists of devices that are exposed to the internet. The most common of the devices are normally like switches and routers. For example, the router in your home acts sort of like a router and a switch and a modem all in one. But essentially, the router in your home has a public IP address which anyone can connect to. So if you guys remember the IP that I have previously, that's essentially my router's IP address. But of course, the devices connected to your network, the devices connected to your router, like your phones and laptops, will never be exposed to the internet, and they'll only have one private IP address. So if that's the case, we have to ask, how do our devices connect to the internet? And like Yongjun mentioned before, we have something called network address translation, or NAT for short. So what NAT does is it takes your private IP address and it hides it from the internet by putting it behind your public router's IP address. And to better understand how NAT works, imagine that we need to send a letter to a friend. So data on the internet must have a source and destination address, much like how letters have a sender and a receiver. So in this scenario, let's say you fill in your home address as a source, and you fill in your friend's address as the recipient. Now let's say that Singtel offers a privacy feature like NAT, where they hide your home address behind their own SingPost address. So what they do is they take your letter and they mark it with a code, and then they erase your home address from the letter, and they replace it with their own address before sending it off. So your friend in this case, when they receive the letter, they'll only see SingPost as the sender. And if they want to reply to the letter, they can send a reply back to SingPost along with the special code. Then when Singtel receives the reply, they simply look up the code and they figure out where the letter came from, and they send it back to your home address. And this analogy is essentially how NAT handles the translation of private and public IP addresses. So in summary, the internet is basically one large network of networks which consists of computers. And the internet protocol basically helps us find computers on this network. Just remember that there's a distinction between public and private networks. And to convert between public and private IPs, we use NAT. Now, just keep this model of the internet in mind, because when we scan for devices on the internet, essentially we'll be looking at this. I want you to keep this model while you scan for devices on the internet and scan the IP addresses. And now that we have a way of finding devices on a network, we still need to find the programs that run on a computer, right? Because what's the point of connecting to Google's computer if you don't know where YouTube is running, or if you don't know where Gmail is running? Because one computer can run multiple services, we need to identify every service uniquely. To do so, we use a port number. Essentially, while an IP address lets us find a computer on a network, the port number lets us access a specific program on the computer. And using the analogy of an IP address being like a physical address again, a port number would be like the room number of a building. So if you have the host IP address, and if you have the port number, essentially you can find the specific building and the specific room that's providing the service. So just keep in mind again that to find a specific program on a computer, we need both the IP address and the port number of the process. With that, you have about the fundamentals required for how to use a network scanning tool. And we won't cover too much in depth about networking because it's quite a heavy topic, but if you'd like to learn more about IP protocols and the computer network in general, I'll add more links to this page, but essentially we will have a few resources for you so that you can read in your own free time and explore computer networking when you feel like it. because it's honestly a very heavy and very big subject. So I don't think we can cover this in 1 hour, but it's very important for you to actually go through this. And now I'll hand over my time to Chris to talk about scanning. Chris, if you'd like to take over the screen.
Yep, give me a sec.
In the meantime, let me just go through the Padlet and see if there are any questions we'd like to answer.
Okay, so hi guys. My name is Chris. Can you guys hear me properly with my mask? If not, I can take it off, or is it right? Okay, thank you. So hi there, my name is Chris, and I'll be introducing you to some scanning tools. So for today, we'll be covering Nmap. We have covered a lot of the theory and scanning and networking basics, and you're now ready to take some hands-on. So Nmap is a network scanner that's very popular amongst ethical hackers because you can see that it has a lot of powerful features that can make use of. Some of these features include finding out what hosts are available on your network, or what services these hosts are offering, or what operating systems they're running. And most importantly, Nmap is free and has a strong community following, so you can find a lot of community guides online. So there's also an Nmap additional resources slide here. Before we begin, there's one thing to note that Nmap has a lot of useful switches that you can use. So what switches are? They are basically options that you can add on to your Nmap command so that you can have a more customized scan. So to get a list of these commands, you can open your terminal and try nmap-h. It should give you something like this. Sorry, let me open your terminal. So if you have downloaded Nmap successfully, you should be able to see all these switch options that you can use. So the important thing here is that you don't really have to memorize any of these options that we'll be covering through in the next few slides. These are very easily available on your terminal, or it's also available online. So you can refer to this cheat sheet. Yeah, so make sure you don't memorize these features. Like no one does that. You can always Google it. So for the first hands-on, you can first start by taking out your terminal, and you can run the following command. So I'll give you guys about 1 to 2 minutes to just try it out. And you could raise your hand in the Microsoft Teams to indicate that you have successfully run the program. If anyone has any troubles, please let the chat know so that someone in the Exco can help you with the debugging. Yeah, that's good. Okay. So when you run the scan, you should be able to see something like this. You'll see a lot of things like ports, state, services. Based on what we have learned earlier in the networking basics, you should be quite familiar with ports already. But something new that may not have been covered would be this state. So what do closed ports, open ports, filter ports, what do all this mean? And we have to understand this in order to make full use of this information that we have gotten from the scan. So to run through the different types of ports, we have open ports. So open ports are applications that are actively accepting connections. This means that the scan from Nmap has successfully established a connection from your computer to the server. And what this means is that anything that has an open port could be used as a primary target for your hackers because they represent a publicly accessible service. On the other hand, we have closed ports. So closed ports are the most common type of ports that you'll see. These ports are normally mean that no application is listening. So your scan sent a packet, but the server didn't send anything back. Oh no, this it just means that there's no applications listening on this port number. So they still receive and respond to Nmap SIM packets, but this means that they're still useful for host discovery, ping scanning, and OS detection. Normally just to find out what device is running on this IP address, but not so much about what applications are being run. The last would be your filtered ports, which is probably the least useful ports that you find, because these ports indicate that the SIM packet has been blocked. So normally this is due to firewalls or packet filtering. And these filtered ports normally provide little information and will slow down your scanning. So now that we have learned all about these ports, before that we have one interesting activity to do. So based on what you have learned earlier on your IP address, we can actually find out who's on your network. So if you try this command, nmap-sp, and then insert your IP address in your terminal, you'll be able to see who's on your network right now. So you can take about like 2 minutes to try this also. Sorry, I only have one screen, so sometimes you'll see Brian's face when I type out, but hope you don't mind. In the meanwhile, does anyone have any questions or stuck with Nmap? Right, so in this case, I think when we're scanning public addresses, it's always good to try to mask your IP. But in our use case, since we're just scanning our own network, I think it should not raise any flags. Do make sure that you're trying this when you're at home. If you're in school like me, try not to run it, because I think that is, yeah, maybe the school will like pick up your IP and block you or something. So do try this only when you're at home.
Perhaps I should demo it because I'm at home.
Yeah, okay. Brian will take over control for a while.
Yeah, I think it's a bit risky for Chris to do it because SMU has a pretty strict policy on these kind of things. So like Chris mentioned, we'll be using Nmap. And for Nmap, my address was let's say one. If I do this, am I missing anything? Start it and it should get me some data. And Nmap takes a bit of time to get warmed up, but once it starts and establishes connections, it should be pretty good. So give it some time, and if this crashes now, it'll be kind of awkward, but you know, we'll make do.
I think you're running a full scan because you didn't do
Yeah, I forgot about
-ft.
that. So I just skip ports. I definitely missed a thing. There we go. So essentially what we did was we went through every single IP address, and we figured out that there are a few devices that are running on my network. In this case, 1, 2, 3, 6, 110, 125, 43, etc., etc. So again, like Chris's slides mentioned, let's put this here. SP is essentially we're skipping the port scan, so we're not looking, like we mentioned, our previous analogy was that the port is like a room number, right? So if you don't skip the port scan, we're basically going to every single house and we're checking every single door in every single house. But if you put SP, we're asking Nmap to just ignore checking the doors. So we're just looking for houses on the street, for example, rather than going to every single house and checking every single room, which takes, as you realize, a really long time. And /24 is just what we call a 24-bit net mask. So a net mask is what we use to separate the public and the private IP addresses. And we didn't have much time, but if you'd like to cover that, we'll add it to the additional resources in the slides further down below. I think that's all. All right, Chris, you can take back, I guess.
Thanks, Brian. Okay, so back to the slides. So just now we saw that Brian's first initial scan took very long. It's because he forgot to add this option. So normally in this case, it depends on what your use case is. So in this case, we're trying to find out what devices are listening onto your, or what devices are connected to your network, and not so much about what applications are being run. So in this case, you can afford to skip the port scan because this will help you to save a lot more time. So it's always important to look at your use case when you are trying to run a scan to optimize. Yeah, you only have so much time in a day. You don't want to waste so much time doing other things. So another thing that we could try now is another hands-on. So this time we can try running these two scan commands. So what we're trying to do here is that we're trying to scan me.nmap.org, and we're trying to scan it for any open ports. Once again, to reiterate, scanme.nmap.org does give, sorry, let me get out these slides for now. Scanme.nmap.org gives permission to scan them. So, yeah, over here it says you're authorized to scan this machine. So that's why we are trying to, using ScanMe in this case. Do not try to scan other random websites because I think even though it may not be entirely illegal, normally system administrators do not take so kindly to it. So do try running this too, and you should be able to see, should be able to try to look for any differences in the results. Okay, so I'll also try running on my end. Okay. If there are any other questions, or do feel free to add it into the chat in the meantime. So just let me run, sorry. So in this case, you may see, in this case, you may see over here that you may have a scan type that requires root privileges. So in this case, you have to add a sudo command in front for Mac users. For Windows users, Brian, do you happen to know what the sudo equivalent is for Windows users?
Honestly, no idea. I don't really. I think you had to. Sorry. I think you had to run the CMD as an administrator. So close the terminal and just right-click on your CMD and run it as an administrator, and that's how you get root privileges.
All right. Thank you.
It's been like 5 years since I used Windows, so you might be wrong, but
same.
Try that out. Yeah.
So in this case, what sudo does is that it allows you to run as an administrator on the Mac, and it allows you to grant root privileges when you're scanning or performing scan type. Okay, so now that's done, you can see that one difference here is that for your first scan, you run it in 2 seconds, for your scan 31 seconds. Is in, sorry, let me open the slides again. So the key difference is in what scan do. The first one does TCP scan, the other one TCP. And one key thing to why there's a difference in timing because CScan the CScan performs 2 steps of the distribution check. So what happens here is that it sends a synchronization packet and right there, and it comes back and say, hi, I received your message. But after that, it stops and resets. But for the other side, TCP Connect Scan performs the full confirmation. So after it says, hi, I received a message over here, you send back another message saying, hi, I acknowledge your acknowledgement. So in so doing, it actually takes more time with the TCP Connect Scan. However, one thing about SynScan is that it does not send like a complete connection. So it performs an incomplete connection over here. And some networks may see this connection as invalid and try to block it. So sometimes if you realize that your SynScan is not working, you may want to try other kinds of scans to get to your end goal. I think in this case, you may also see some variation in the network timing, depending on how much load the server is getting. So in my case, actually, there was my TCP Connect scan did take longer than my SYN scan. So there's also other reasons why there's variations in timing. But in general, I think you should always try to start with something that's stealthy. And I think SYN scan is generally because it's faster and stealthier. And yeah, so that's something to keep note of. Okay, so for the next one, this will be a bit more challenging. So last week, we were exposed to the idea of capturing the flag. And the one key thing about being an ethical hacker is not so much about learning all these tools, but it's also about finding a way to make these tools work for you. And there's normally an end goal for it. So in this case, we'll give you a scenario. You're given an IP address of 45.55.44.245, and you hear that somewhere between the ports 0 and 5000, you can find a flag. So just based on these clues, if you're a bit more experienced, you can try to solve it without looking at clue 1 and clue 2. But for those who are newer to Nmap and not really familiar with scanning, clue 1 says that you should do an Nmap scan to find the ports. So you can add this option here to modify your search terms so that you only scan the relevant ports because you know it's between ports 0 and 5000. And then after that, once you get the open ports back, you should be trying to find out how do you access the ports. So you guys can take about 5 to 10 minutes to try to figure this out. If you have any issues, do let the chat know so that ESCO can help you. I'll leave my slide on. So in the meantime, is there any questions on the palette, Brian, that you want to clarify?
All right, so right now we don't really have much questions. We have a few about the whether you should hide your IP address and why you would get banned. And I think this is a pretty interesting question. So somebody asked, why would SMU administrators try to block you if you try to use Nmap on the school network? And essentially, it's about controlling the volume of network activity, as well as controlling the network activity to prevent any sort of security issues or potential privacy issues. So for example, because Nmap is constantly creating connections to find hosts and find services, it creates a lot of network activity and a lot of connections being thrown up throughout the network. And with SMU's network being so large, it becomes a potential bottleneck in the performance if someone were to allow random users on the network to just start creating these scans. Because if one person is doing an Nmap scan, that's fine. But if multiple people are doing Nmap scans, or if somebody launches a denial of service attack on the SMU network, it causes a problem for everyone on the network. and we'll be talking about DDoS, distributed denial of service attacks in the future. So don't worry too much about the terminology again, but if you're interested, you can always search up DDoS. And as a privacy and security issue, it might be an issue if one user on the network is allowed to start scanning the network for other potential users on the network. And of course, as a school, they'll want to minimize any sort of privacy and security issues. Therefore, if they notice one device creating all these different connections to different devices within the network, they'll try to stop that thing.
I think some of you guys are maybe facing long scan times. I think this may be due to server overload, is it, Brian? But I think give it some time. It can take anywhere between a minute to a few minutes. Sometimes.
I think we should limit the range from 0 to 3,000 because, like I said,
right. Okay, we can try to limit it to 3,000. So is
the hit is below 3,000. Yeah, I think.
So for port numbers, it can go as high as 60,000, 65,000. So normally you wouldn't be given you wouldn't be knowing that, hey, there's 0 to 5,000. Normally you will try to do a full port scan. But in this case, you can try to limit to port 0 to 3,000.
Yeah, I think with 75 people here.
Yeah.
Everyone running a scan, it might be killing
the server.
Oh,
right. Okay.
Okay, let me see if I can fix this quickly.
So Netcat is a tool that you can use to make.
It's working fine. It should be fine. Just give it some time.
So Netcat is a tool that you can use to try to assess a port. So I think when you downloaded Nmap, it comes with Ncat for Windows users. I think for Mac users, you may have to do a brew install. But in this case, if you already have another tool like CURL, a hint is that it's over HTTP also, right, Brian, for this?
It's actually just a general it's a general network connection. Right. So Netcat essentially is a networking tool that programmers can use to essentially debug network interfaces. So last week we used CURL, which is basically a network utility for HTTP interfaces. So it's used for like web services and any sort of things that's built over HTTP. But Netcat is a more general purpose utility that lets you scan for networks, so you download an interface with networks without any sort of restrictions on what type of network it might be. So it should be pre-installed on Macs, but if not, then you can use the link that we provided in the slides just now to download Netcat. Or if you guys have set up the Homebrew installation, you can use Homebrew to basically install Netcat onto your Mac without using any sort of downloads. You just type in the command line and it'll download it for you automatically. Yeah, I hope that answers the question. If you're unable to run Netcat, Netcat, try to run NC. It's a short form for Netcat. Shortcut.
So if you have Netcat installed, you should be able to see something like this when you write NC. But I did a brew installation yesterday actually, so I don't think it comes default. So you may have to. So in this case, I'll brew uninstall Netcat.
If anyone's found the if anyone's found the flag, just put it into the chat. If not, then we'll revisit the exercise. Yeah, nice. Kenneth.
Oh, nice.
Nice, just keep sharing. Nice. Unfortunately, we don't have a platform for you to submit these flags to earn any points, but in the future, if you actually do participate in any sort of CTFs, they might give you hints like these. They might give you a cheeky title, and you just have to figure out based on the hints. So normally, if they give you like just an IP address, personally, I would just start with nmap because you never know. Of course, there might be other things that you might need to configure, but this is a pretty simple exercise, and I hope you guys have fun with this one.
I think we can start going through the solution, right? For the nmap, for this capture the flag.
Go for
Brian?
it. Yeah, go for it.
Okay, so based on this scenario, what would be your first intuition? I think, sorry, give me a sec. So in this case, you know that the IP address is actually 45. Let me bring it out. Okay, yeah.
45, 55, 44, 245.
All right. Okay, so let me explain what this does. So in this case, one of the chat questions was that why is the scan taking so long? So one thing we can do actually to expedite is that we can skip the ping scan using the -pn option. And then, like the other clue said, because we know that it's between 0 to 3000, you can limit your port scan to 0 to 3000 actually. So let me just see. Oh no, okay. Maybe. Is the port down?
It shouldn't be. I just used it.
Oh. Was it because I'm in school? That doesn't make sense though.
That doesn't make sense.
Yeah.
Run it.
Let me try one more time.
45, 55, 44, 245.
Correct, right? Yeah.
If this doesn't work, that's kind of awkward.
But I actually ran it earlier, so it worked just now, but I can just refer to that now. Give me a sec.
No, it's working, it's working.
Interesting. Okay. Maybe I'll just show the results I got earlier. We'll figure out why the 2389 is not showing now.
It's right there. It's right there.
No, this is I ran it just now, but over here was 2000 only. So that's very strange. But anyways, so over here, the first intuition is that you have so many open ports. So you try to check which ports are accessible. So in this case, normally SSH is something that is always running. So there's not really much point to actually try assessing it. And so as your domain service also, I think one thing that you see here that's not really like familiar for people who normally scan ports is this OV session manager thing. So you can try assessing this through ncat first. And for people who are using ncat, so ncat, in order to specify the port that you want to access to, you have a space and then you put the port. And you're able to find the flag. So normally you try to, what you do here is that based on your knowledge that what ports are accessible, so you have open ports, and also based on a bit of trial and error and also a bit of luck, you can try all the ports that may be accessible, and then you can try to eventually arrive at your flag. So that was my attempt. I'm not sure how Brian would have tackled this. Is it similar?
Same thing. Yeah, same thing.
Yeah. So in this case, this will be your solution in a way. And for Windows user, you'll be using ncat instead of nc. So for, we don't really have much time now. We have 5 minutes left. But these are a few extra hands-on that you guys can try in your free time. In this case, this hands-on is meant to help you detect the OS. And one of the things that we can notice over here is that sometimes you'll see that there's no exact OS matches. But what is useful here is that you can still look at the fingerprint for some information. Like normally you can look through the results to try to still squeeze out some information. So in this case, you know that the user has an Apple Mac and is running on this version of the Apple OS. And then there's another hands-on over here that you can try in your free time. And a few questions for you to try out to sort of consolidate what you've learned today. And the answers can be found afterwards. So for the next lesson, we'll be learning more about the OSI model, which is a more abstract understanding of how networking is split into 7 different layers. We'll also be learning a bit more about DNS basics and packets, and the hands-on will be with regards to packet sniffing. So you'll be able to really go into the specific details of like what's being sent on your network. So next week will be pretty interesting. I'll pass the time back to Brian.
Yeah, so somebody's mentioning that probably the school network's actually blocking some of the ports that you're using, so that might be a bit difficult for anyone in school to actually use Nmap. So that's one of the issues. And like Chris, should I take back the screen?
Yeah.
All right, so like Chris mentioned, our next lesson will essentially be covering the OSI model, and I think I gave you guys a little bit of an introduction to OSI. Basically, it's about how data is physically transferred between devices. DNS, which is basically a domain name system. So how do you go from google.com to, let's say, 8.8.5.100? So basically how they convert the text, the URLs that you're used to the IP addresses. And we'll be using Wireshark. So I hope you guys do install Wireshark before the next lesson to minimize any sort of issues. So there are a lot of tutorials online, but again, we'll link to a few resources that we think are useful. So just keep in mind for next lesson, try to get a Wireshark. And we have 3 minutes left and basically an hour of discussion. For anyone who was here yesterday, last week, I have a little bit of an OSINT exercise for you guys. So we gave you the IP address of the service I'm running, right? So we gave you 45.55.44.245. So let's have a little bit of an OSINT challenge as well. So treat this like a second CTF challenge. What's the service that I'm using to run this application? If you can figure that out, just put it in the chat. And so going back to your OSINT basics, this is basically your public resources, your reconnaissance. So if I asked you, there we go. That's fast. Yeah, basically it's Google searching, right? So Yinkiat, would you like to share your solution, how you solved it, or should I just walk through it? So if you guys remember from last week, essentially OSINT is just about using public resources to find information about the target, right? So since we have an IP address, okay, so Kuratu, you're using Windows, right? Because a batch file, essentially, it's a Windows thing. So for Windows, NCAT isn't pre-installed. So you have to install Nmap through, so you have to install NCAT, which is basically Nmap's version of NC. So, okay, so what Yinkiat did last week is that we basically went through OSINT and reconnaissance, which is basically just Googling. So first things first, I'll probably say IP look up, get details. And there is an instant IP address lookup thing. So let's visit this. So this site gives me a little bit of what's my IP address. So let's say if I put it in, yeah, it's as simple as that. Google searching, and it tells you that it's registered to DigitalOcean. So these kind of challenges are pretty simple, but I hope that what we learned last week helps you guys think of different things you can do with any sort of public information. So I released this, and you can figure out what my DigitalOcean is. I think something that'd be fun is for OSINT as well, if you can figure out my username, I guess, my username on DigitalOcean or GitHub. If you can figure that out, that'd be pretty cool. But for those of you who are new to this workshop, essentially OSINT is just the idea of using public information to figure out any sort of vulnerabilities in your target or any sort of potential weaknesses. So of course, given that I've given you this address, there are a lot of things you can do. So one thing was basically finding the service provider for my IP address, and you can probably do other things as well, including, I don't know, you could try looking for my DigitalOcean account, perhaps. These are all little challenges you can always try to do. And if you are going to hacking and pen testing, I think it's a pretty great mindset to essentially always try to always try to have fun with any sort of data that you're given and try to see how far you can take that data. So with that, I think that's the end of our workshop for this week. And for now, let's just go through any sort of debugging for the workshop. Can't reassign. Give me 1 second. So Kuratu has an issue with NCAT, saying you cannot resolve. So yeah, so NCAT actually requires you to use a space. Was it different in the slides? Oh yeah, here. Sorry about that. So basically use a space, and yeah, sorry, I didn't catch that either. It's my bad. Thanks again, Waitak, for helping out with the debugging. So nice, you got it. I hope that was fun for you. So someone asked a question about can't assign requested address 49. And as far as I'm aware, this is basically just a bug. So not being able to access it, it's just a bug with macOS's installation of Nmap. So there are two ways you can solve it. One is to restart your computer, or otherwise you can always try to reset your network interface. So based on what your network interface is, whether it's a USB, a landline, or a Wi-Fi network, you can always try to reset it, but it's no big deal. I don't think it will do anything for you, so don't worry too much about it. Yeah, thanks to whoever's typing that up. Super useful. So can I just ask how many of you tried the other challenges in Pico CTF? And I just realized for the new members in the workshop, if you are looking for a quick and easy all year round CTF competition for you to try out, do visit PICO CTF. It's basically a free resource for you to actually try out different cybersecurity competitions. So it's beginner friendly. It's very I think it's pretty fun, especially if you're starting out. So for the new members here, just give it a try. And Yi Hao's tried some, it's great. So these are really fun. So let's see if there's anything that we can try out. Okay, they don't have any scanning stuff today. Never mind. But in your own free time, if you like to, you can always go to that website to just try out any sort of resources. We have hands being raised. Gerald, any questions? Or Lindy or Leah, if you have any questions, just you can always turn on your mic, or you can just type into the chat.
Brian, I think they may have raised their hands from just now, so they may not have questions.
Oh.
Yeah.
Okay.
Yeah, thanks for joining us today. Do help us fill in this feedback form if you have time, or if you have any comments for today's session. But yeah, thanks for joining us.
Thank you, Waitak. Always means a lot. And thanks, Gerald. So hi, so what command exactly are you using? So with nmap, let's see what's the exact command you're running. And we can try it out together. Okay, so hi, so essentially what you're doing is you're scanning your own device. So 192.168, it's basically your local network. So what happens is that you're basically looking into yourself, and don't worry about it. One security, I guess, unintentional security feature of having a private and public network address is that even though you exposed your private IP address, your 192.168 dot something, because it's a private address, I have no idea where you actually are. So even if you told me, oh, my address is 192, the thing is I can't access your device. So don't worry about it. And that's another security feature of private and public IP addresses. In fact, I shared my public address, but I have faith in my firewall. And also, Singtel actually rotates your IP every 2 or 3 weeks. So after 3 weeks, it should be gone. Besides, there's nothing critical on my IP address. Just don't launch any sort of DOS services on me, please. Yeah. And Yihao, I have no idea what 19.4 is, but I can always give it a little search. nmap is a very, very old tool, so it's been around since forever. So it's unsurprising if it's been there since the very start. So perhaps let's run through the flag challenge again. Let me just share the content again. So maybe it'll help if we just went through the content again. So basically what we're doing is the address is for something. Just trying that. So what we're doing is we're saying nmap. Okay, what? Yeah, nmap. We want to scan the port. So dash tiny p. Tiny p is port. Just make it big and nice and big. Right. Dash p is just for port. We're saying you want to scan from 0 to 3000. By default, nmap only scans from 0 to 1000. So we put this here to tell nmap to basically scan more ports. And -pn is just skipping the ping, which helps speed things up. If anyone would like to help me define that more clearly, be my guest. So this command essentially asks Nmap to start and send different connections to every single port on this specific IP address. So it'll send a connection to 0, it'll send 1 to 2 to 3, 4, etc. to 3000. And if any of the ports reply with any sort of responses, Nmap can kind of figure out what's going on there. So if it's open, it'll send an actual response back. If it's filtered, essentially it means that nothing happens. It's blocked, it's filtered. And if it's closed, it just means that the port is actually turned off. So the port will send the computer will send back a closing, I guess a termination packet or termination command that tells Nmap, oh, I'm closed. So again, if you'd like to clarify that again, we can always go through the slides, but you guys should have access to the slides and you can always go through the content there. So Nmap finished scanning and you notice that over here I have port 22 and port 2389. So 22 is a really common port for something called SSH. You don't have to worry too much about that, but if you're interested, again, you can always search it up. SSH is basically it's a way of accessing computers remotely. But don't worry about that. So we have port 2389 being exposed, right? So you just type ncat, or for Mac users, it's ncat or nc. And for Windows users who install nmap, it should be ncat. Wait, what? I have ncat? What is that? Oh, I have ncat. Cool. So let's use ncat. The port number is 45.44. No, this. So yeah, 45.55.44.245, and the port was 2389. If I hit this port, I get the flag, and that's the end of the challenge. So let me know if that works for you. And for everyone else, if you guys have no other questions, and if you have no other questions, you're free to. What if you try to get into the shell of the computer? If you'd like to know more about SSH, okay, so a few questions here. So how do you get into the shell of the computer? That's a different thing, but SSH basically gives you a remote shell, and SSH uses a different protocol, so it's actually, you won't NC. So if I try to NC this, let's just try it out. It'll tell you that it's OpenSSH, but that's it. You can't really do anything. So you notice a protocol mismatch. So essentially, NC is a general purpose network utility. So what happens is that it sends a very generic TCP. We didn't really explain what TCP is, but it sends a very generic data packet to the port, to the host and the port. And because SSH has a certain protocol, it will tell that protocol mismatch and it just won't work. To actually log into a remote, you have to use something called SSH. And if you try to do this, it won't work because NC doesn't give you shell. NC gives you a connection. NC gives you a connection. So just because you have a connection doesn't mean you can get access to it. So there are a few things to the connection, and we'll go through this in the OSI model because there are a lot of steps for these kind of things. But yeah, and if you try to SSH, don't bother because there's no password in this. It's just a key thing. So if anyone else tries to log into my SSH, it just wouldn't work. It's for this device only. I think I might have reviewed my username there, but you know what? I guess that makes it easy for the challenge, right? Nah, we're all good. So I guess bonus marks if anyone can find out my GitHub username. It's not a requirement, just a little bit more OSINT for you guys. LVP. Yeah, so NC-L, L is basically for listening. So like I said, NC is a general purpose network utility. So -L basically asks Netcat to stay connected and stay open listening for any self connections. V is for verbose, so verbose meaning that it'll give you a lot of details. And -P is, I'm not too sure what it is, but the beautiful thing about being a developer or being a hacker is that you have Google. So where would I get all this information? I'll just search Netcat options. Cheat sheets. And this is basically the gist of being a lot of things. You just use Google because nobody expects everyone to remember everything, so it's always available online. So this site is kind of useless. If otherwise, you can always use a man page, so you just nc-h or man nc. So nc-h -h for help, and it'll tell you all the different options. So -v is verbose, which means that's kind of cryptic, but don't worry about that. -p is local port. So basically, it's asking which local port to use for the Netcat connection. And -l is just listen. So yeah. So basically, listen for any sort of inbound connections. So keep Netcat alive and listen for any inbound connections. And I think maybe one thing we can try to do is set up a little chat app between our two terminals, right? So let's say we listen on this network. I'll be verbose and HP 2000. That works. And now over here we type NC localhost. So another thing, localhost is just your local device. So it's just basically connecting to yourself. Localhost 2000. And boom, it connects. So this guy is connecting to this guy who's listening on the port because -L, and -V tells me that there's a connection for myself, but 63801. And there are some things you can do with bash. So nc -out, put in. Yep. Let's say the guy nc his IP address. Is he able to get remote access? So again, it really depends on what you mean by remote access, because NC is just a general purpose utility. So it wasn't really a remote access, it's just a program that's running that's basically saying, okay, I am currently connected to this person and this person is connected to me, but there's nothing happening. It's not that you get access to the terminal, but just that you have a connection that's set up. So remote access, it's the cream of the crop. It's really the best thing you can get, but of course, remote access is difficult to get. So there are exploits that use NC to get remote access, but it's not as simple as using NC to just connect trivially. I hope that answers the question. So hi. In fact, if you would like to, you can always search up Netcat exploits for reverse shell or any sort of remote shell. And if you find anything interesting, just post it to your Telegram group. Just share the Telegram group or share the main group and let us know what you find. I think we'll all definitely appreciate that. Right. Anyone else has any questions or would like to ask? I tried since last year. Oh, it's difficult. Yeah, it's difficult. Remote access really is. It's really the best thing you can probably do. All right. Again, thanks everyone for joining us for the workshop, and we'll be listening onto the Padlet for the next few days. So if you have any questions, just put it there and we will answer as soon as we can. All right. I hope you guys had fun. All right, thank you. Have a good night. Tanya, I think we can turn off the recording now.